Today we are going to discuss MCQs on digital to analog converters. The main disadvantage of a weighted resistor DAC is option A, low speed, option B, high power consumption, option C, requirement of precise resistor values over wide range, option D, poor linearity. Before going to the answer, we can just discuss what is an ADC and a DAC. ADC means it is an analog to digital converter. The input we will be giving the analog signal and we will be getting a digital output. In the case of DAC, that is a digital to analog converter. Here the inputs we will be giving the digital signal and the output will be an analog signal. So there are some general equations which we have to know for solving the problems which is related to the DACs. Okay, the first equation is the output voltage of a DAC can be obtained by V out is equal to V reference into Bn minus 1 by 2 plus Bn minus 2 by 2 raised to 2 plus etc. up to B0 by 2 raised to n. Next one is in the case of weighted resistor DAC, the output voltage can be obtained by the same equation. V out is equal to V reference into Bn minus 1 by 2 plus Bn minus 2 by 4 plus etc. up to B0 by 2 raised to n. For the case of a R2R ladder type network, the output can be obtained as the same equation can be used also. The V out is equal to V reference into D divided by 2 raised to n, where the D reference refers to the digital value of the digital input. For example, 001, this represents the digital value 1, so that we have to give us the in the place of D, and n represents the number of bits. So the output V out is equal to V reference into D by 2 raised to n. The next one important equation is the step size or the resolution that can be obtained by the reference voltage divided by 2 raised to n, where n is the number of bits, where n represents the number of bits. And also the resolution can be obtained by another one equation also, that is 1 divided by 2 raised to n, where the percentage resolution can be obtained by multiplying it by 100, that is 100 by 2 raised to n. Now, the another one important equation is the full scale output voltage, that is VFS, that can be obtained by full scale output voltage is equal to V reference into 2 raised to n minus 1 divided by 2 raised to n. So, these are some important equations which is required for solving the questions which is related to DAC, usually this type of problems. The first one DAC we are going to discuss is the binary weighted resistor DAC. Here in this figure we can see that here it will convert a digital input into corresponding an analog output value, okay, by using the weighted resistors. Here we can see R, 2R, 4R, 8R. These are the resistor values. The resistor weighted is in the power of 2, and also there will be a summing amplifier which is used for this, and with an op-amp summing amplifier. Here we have to know 2-3 points regarding this binary weighted resistors. The first one is it requires an accurate wide range of resistors. So as we see that is weighted resistors will be in the power of 2. So wide range of resistors are required, and also here the output will be proportional to the weighted sum of the input bits. And also this can be usually be used for practically for low bit DACs, that's approximately for up to some cases will be telling us up to 8 bits we can use this, okay, because we are requiring a wide range of resistors. That's the reason why we are usually using this for low bit DACs. Okay, next one is R2R ladder type. Here the main advantage is that only the 2 resistor values are required, that is R and 2R. And here it uses and also a comparator and a logic circuit to convert the analog input into corresponding digital output. The main advantage is that it only requires 2 resistor values, that is R and guessed. The main disadvantage of the weighted resistor DAC is it requires of precise resistor values over wide range, okay, like R, 2R, 4R, 8R, like that it requires a wide range of resistor values. So this is the main disadvantage of a weighted resistor DAC. Now we can move on to the next question. Which DAC architecture uses only two resistor values? The answer options are option A sigma delta DAC, option B weighted resistor DAC, option C R2R ladder DAC, option D PWM DAC. As we discussed, the which DAC is having only two resistors, that is the R2R ladder DAC. Next one, question number 3. Compared to the weighted resistor DAC, R2R ladder DAC offers option A lower resolution, option B easier resistor matching, option C higher output impedance, option D lower speed. Okay, as we discussed, the R2R ladder, it gives an easier resistor matching. Okay, that is answer is option B. Next question, question number 4. The output voltage of an R2R ladder DAC is proportional to option A input code, option B input frequency, option C binary value of the digital input, option C clock period. The answer is the output of a R2R ladder DAC is proportional to the binary value of the. Question number 6. Which DAC parameter affects speed performance most? Option A resolution, option B settling time, option C accuracy, option D linearity. In the case of a DAC, the speed performance mainly depends on option B settling time. Next question. The advantage of R2R ladder DAC over weighted resistor DAC is option A uses more resistors, option B requires precise resistor ratio only, option C slower conversion, option D larger power consumption. The main advantage of an R2R ladder is option B, it requires precise resistor ratio only. Next question. In DACs, the monotonicity means option A output increases for increasing input, option B DAC is linear, option C settling time is minimal, option D resolution is high. The answer is monotonicity means the output will increase for increase in the value of input. The answer is option A. Next question. If a 4-bit DAC has V reference is equal to 10 volt, the step size is. Okay, here they have given that N is equal to 4 and also the V reference is equal to 10 volt. What they are asked to find out? Step size. Okay, so we know that the equation for step size is V reference divided by 2 raised to n. That is equal to, the question they had given the V reference as what? 10 volt divided by 2 raised to n. So 2 raised to 4. So the answer is 10 by 16. This will come as 0.625 volt. So the options are option A 0.25 volt, option B 0.625 volt, option C 1.25 volt, option D 2.5 volt. Here the answer is option B, that is 0.625. Next question. A 3-bit DAC has V reference is equal to 5 volt. What is the output voltage for the digital input 101? Option A 2.5 volt, option B 3.125 volt, option C 3.75 volt, option D 4.375 volt. In the question they had mentioned the number of bit is equal to 3 and also V reference is equal to 5 volt. And also they are asked to find out V out for the corresponding digital input 101. So first we have to find out the step size. Step size, we know that the equation is V reference divided by 2 raised to n. So V reference is 5, that divided by 2 raised to n, that is 2 raised to 3, that is 5 by 8. This will come as 0.625 volt. Okay. Now we have to find out the output voltage V out. So the digital input, the corresponding value is 101 refers to 5, right? So V out is equal to 5 into the step size value, that is 0.625. That is equal to the 5 into 0.625, it will give the answer as 3.125 volt. Okay, so in the options, we can see the same as option B. So the next question, a 6-bit DAC has V reference is equal to 12 volt. What is the LSB value? Option A, 0.1875 volt. Option B, 0.375 volt. Option C, 0.5 volt. Option D, 0.25 volt. So here the value of N is equal to 6 and V reference is equal to 12 volt. They are asked to find out the LSB. The LSB value will be same as the step size. So the equation is step size is equal to V reference divided by 2 raised to N. That is equal to 12 volt divided by 2 raised to 6. This will come as 12 divided by 2 raised to 6. It will come 64, right? So the 12 by 64, that is equal to 0.1875 volt. So the answer is option A, 0.1875 volt. An 8-bit R2R DAC with the V reference is equal to 5 volt produces an output of 2.5 volt. What is the digital input? Okay, here they had given the value of N is equal to 8 and V reference is equal to 5 volt and the output voltage is given as 2.5 volt. They are asked to find out the digital input code. So first here we have to find the step size or the LSB value. So here the step size is V reference divided by 2 raised to N, that is equal to 5 divided by 2 raised to 8. The answer will come as 2 raised to 8, 256, right? That is equal to 0.01953 volt. Now we require the digital input value. For that we have to find V out divided by the LSB value. That is equal to 2.5 divided by 0.01953 volt. This will come as approximately equal to 128. So this is the we have to find the corresponding digital code for this corresponding value 128. Here the answer is option A. Okay, like next question. A 5-bit DAC has V reference is equal to 10 volt. The maximum output voltage. Option A, 9.375 volt. Option B, 10 volt. Option C, 9 volt. Option D, 10.5 volt. Here number of bits N is equal to 5 and V reference is equal to 10 volt. Here we have to find the step size. Step size is equal to V reference divided by 2 raised to N. That is equal to 10 divided by 2 raised to 5. That is equal to 2 raised to 5, 32, right? So 10 by 32. So the answer is 0.3125 volt. The question, they had requested to find the maximum output voltage. Here in the question, it is mentioned that it is a 5-bit DAC. So the maximum value which is corresponding for the 5-bit is 31. Okay. So the maximum output voltage will be 31 into 0.3125. So the answer is option A, 9.375 volt. Okay. This is the answer. This is an approximated value. Okay. Some difference is there, like it will come 9.6 something. So the answer is 9.375 volt. Okay. Next, number 14. A 12-bit DAC has V reference 10 volt. Calculate the step size. Okay, we already done so many questions. So step size, we know that the equation is V reference divided by 2 raised to N. So here the V reference is given as 10 volt and the number of bits N is equal to 12 volt. So the answer will come 10